And welcome to Molloy 2010 TQ. Okay, so it's recording my voice. If you can see the little bar down here, that tells the sound level. Okay, so I usually have a wireless mic so I can walk all over the room, but I got to be close to my Skype mic. You ever do Skype? That was my kid Skyping me. Did you see that? Yeah. He's off at Alfred University, so we Skype. So it was funny. I was Skyping my wife's great uncle yesterday. And he's like, wow, this is like a Dick Tracy phone. So anyhow, so let's start doing some stuff. So if you turn to the next page in your packet. All right, what I did, I just gave you a sample of some work that we do in my pre-calc class. These are some quizzes from chapter 11 of my pre-calc class. So the question number 1 says, solve the given system of equations algebraically. 4x plus y equals 0, 6x minus 8y equals negative 19. Use the elimination method. I would have shown you that on my smartboard. Next page. Okay, and solve this given system using an augmented matrix. Well, before we do that, how would you do it on a graphing calculator? All I'm looking for is a point of intersection of two linear equations, right? Okay, so what I do is I start up my virtual TI. All right, this can go out of my way. This can go out of my way. All right, virtual TI. Ding. All right, now I have my choice. I've used over the years every single TI there is, except for the Inspire. Sorry, me and the Inspire, we don't get along. I don't know why. It's just, I've tried, but I've used a TI 82, 83, 84, 85, 86, 89, 92, 200, Voyage. Yeah. So I got them all here. I guess. What do you guys use? Do you use graphing calculators? What? 84, 83, like that, right? All right, so put up I have an 83 here, so it should be fine. All right, so let's do this. VTI is a free program that someone wrote. It's a Z80 microprocessor emulator. The old TI graphing calculators had a Z80 chip in it. So what they did was they created this thing called virtual TI. You can Google it, download it, it's free. It's VTI for short. And what you do is you hook up your calculator. You have to own the calculator, otherwise you'll be breaking copyright rules and TI will put you in jail. Okay, get your calculator, link it with your computer, run VTI for the first time. It says, where's your calculator, right? So you link it up, and it downloads the operating system from your calculator to the Z80 emulator. That's all this is a Z80 emulator with some fake pictures. That's just a picture of a calculator, okay? But I use it in class all the time, just like a calculator, because I've downloaded the operating system, like I said. So I usually put that over here somewhere. Whenever I need it, it's there. I can resize it. I can make it really small, really big, whatever. Alrighty. And so who needs TI Smart View? This is my Smart View, basically, right? So, all right, so if I turn this on, I can clear out stuff I did yesterday, and we're ready to go, okay? Now, I really wish I had my smart tablet, but my kid put my power cord somewhere weird. So sorry, I apologize. I never do this. I haven't touched it. Literally, I have not touched this in at least 10 years. Okay, so we've got 4x plus y is equal to 0. We've got 6x minus 8y is equal to negative 19. What do you got to do first? So you can solve it graphically on your calculator. Get y alone. All right, so y equals what? Negative 4x. Negative 8y equals what? Negative 6x minus 19, then I'm pretending you're a class. So y is 6/8 of x plus 19/8, and you can reduce it if you like. Okay? So we'll enter that into the calculator and see what happens. All right, so go into y equals, and I got stuff there already. Goodbye. All right, so what is it? Negative 4x? Negative 4x. This is easier with a regular mouse. Enter. And how about 3/4 of x? 3x over 4 plus 19/8. And that doesn't reduce, so we'll leave it like that. Okay, I like to use Zoom 4 usually. Zoom decimal. Zoom 4 is nice because it's square and friendly. You know, you have this battle with the kids every year, at the beginning of the year at least, about getting a good window, right? Getting a complete graph and a good window. What I like for a window is that it's square. Circles look like circles, 45-degree slopes look like 45-degree slopes, stuff like that. And friendly. When you trace it, the x values are predictable. And that zoom 4 is automatically there. And if you don't like the size of the window, go to the window and multiply your x min, your x max and y min, y max, everything by 2 or something, and you're good, right? I don't know, do you guys use zoom 4? So I know a lot of people use zoom 5 or zoom 6. Zoom standard, I can't stand it. Yeah. All right, so look, there's a solution here apparently. There's one point of intersection because they're not parallel. And how do you get it on your calculator? I'm pretending I use a calculator. Right, so my kids, you know what my kids call this? Super trace? Okay, so let's super trace, second trace.
Are you saying with that window, if you use trace, you get exact value?
You may, I'm not assuming that. Yeah. Let's see, 5. And since there's only 2 curves here, I just have to go enter, enter. I don't even need to guess. And the roots, well, the solution is -1/2, comma 2. Okay? All right. That's enough graphing calculus. Now let's show you the real thing. All right, are you logged in? Yeah, just click on that thingy. There should be a Firefox icon somewhere at the bottom of your screen, I think, once you log in. Is there a Firefox thingy?
Yeah.
Yeah, open up Firefox. I'm going to show you something called an online computer algebra system, sort of like Mathematica. Has anyone ever heard or used Mathematica or Maple or MATLAB? Any of those things? Well, they cost an arm and a leg. This one's free, and it's online, and it's running on a supercomputer for anyone to use, anytime. But it's optimized for Firefox, for, I think, Chrome. I'm not sure about Chrome. And Safari for Mac users. Okay, so make sure you use Firefox, okay? So this is what you can do. You're going to go into Firefox. And you're going to go to, let's go here. There's a lot of sites. This is the one I was told to use so as not to have too much traffic. Demo.sagenb.org. Okay, SageNB stands for Sage Notebook. It uses a notebook paradigm just like Mathematica. What it does is it combines lots and lots and lots of free Linux open source software that does math under one umbrella to make it, whoops, what happened? Did you guys get there?
Yeah.
You got there? And I didn't get there? Yeah, it should look like that, right? Did you get in? Yeah? Okay, wait, hang on. Did I type it wrong? No. There you go, okay. All right, now, obviously you don't have an account, right? Have you ever used this before? No. All right, so go into sign up for a new Sage Notebook account and make up something. And this is an instant account. You don't have to check your email or anything, all right? So let me see if I can make up one that I don't have on here. I think this one I didn't make. Yes, okay. All righty. And so now use that username you just created and the password you just created. And you're in. Okay. So does everyone have a page like that? Everyone should be logged in? So you can follow along. You can do everything I'm doing. You can do it. Okay? And remember, I'm recording this as a screencast. So if you want to view this later on my YouTube account, it's going to be there later tonight or tomorrow. Okay? All right. So see where it says New Worksheet? Just click on there. And I don't know. I'll call it T cubed or something. So here we go. Give it. It asks you, for a file name, so I'll give it a name. And this is a little slower because I'm on the wireless. You guys, you're slow too, really? I was told to use this site because it's not used that much with spam. Maybe I'll switch to a different site. But all right, hang on, come on. It shouldn't take that long. I tried it the other day. It was good. Did you get to log in? Okay, you're logging in. You're logging in. Maybe the network here isn't that great anyway to begin with. Really? Okay. Yeah, usually this doesn't take that long. It takes like a picosecond and you're on. And I tried it before. I was here for a talk with Dan Davidian right before lunch. I was playing around. It was working perfect. Huh?
We're all waiting.
Apparently. Well, she's waiting to log in fact. You're waiting to make a file name. She's waiting to log in. All right, wait. Let me see if I can try another site. Well, while we're waiting, let me just show you something. If you want to learn how to use Sage on your own, because I'm just going to give you a very brief introduction, obviously, today, you can go to www.sagemath.org, which originated at Harvard by a professor by the name of William Stein. He came up with the idea about 5-10 years ago. And it's been growing ever since. There's a whole community of math professors and researchers that are always working on making this more and more robust and more user-friendly, more and more powerful, and more available to everybody. I don't know. We used to have Mathematica at Baldwin. I have as I said, a supercomputer in my classroom. It's made up of 25 PCs. Each one is dual core, so it's 50 cores. Mathematica costs $99 per core, and that's not a license. That's not to purchase the license. That's to rent the license. You have to pay that every year. So we're talking about 50 cores at about $100 each, $5,000 a year. Yeah, we couldn't do that anymore. So I was looking for something free or cheap, and here it is. Okay. All right. So if you want to find anything you want to know about Sage, go to sagemath.org. Are you still waiting? You're in. Okay. Okay. So you have to click New Worksheet in the top left-hand corner, and everyone then makes your file name, and let's see if I can get in there now. Come on. Not you. Oh, it's Firefox, right? Boom. Okay. So I'll just call it something like T cubed 2010 or something. I don't know. All right. So that basically makes a file for you. It's a notebook. You actually can take notes here in math class. You can write stuff. Okay. So let's do this same problem right here. Okay. Let's say I let f of x. Let's go right here and click in the cell and type f of x. You can call it y, but I'm just being fancy. F of x equals, what is it, negative 4x? Now this is not like the TI in that it understands 4x means 4 times x. You have to do explicit multiplying, okay? All right, so there you go. And that was what, shift 8 for the multiply. And then let's say g of x is equal to 3/4 x plus 19/8, right? So 3 times x divided by 4 plus 19 divided by 8. Divided by 8, oops, okay. All right, and then if I want to check that everything's been inputted correctly, I could say show f of x and click evaluate. And that was f of x, right? And I could do show g of x whenever I want, anywhere in this worksheet. All right. I clicked something called typeset up here. Have you ever heard of pretty print on the T89? I like that. It's sort of like a pretty print. Okay. So I always put typeset up there. All right. Now, what if I wanted to do it graphically, like I just did on the TI graphing calculator? I would have to do this. Go to another cell. Now, if you don't have an open cell, you can drag your mouse until you see a purple line and click on it, and you'll get another cell. Actually, now I made too many. See, now I have a whole ton of cells that are empty, right? So as long as you have an empty cell, do this. Plot f of x. F of x. So let's start with f of x. And click evaluate. By the way, shorthand for clicking evaluate is shift enter. You can do that instead of clicking evaluate. And there is y equals negative 4x. All right. But is that a square window? Does that look like a negative 4 slope to you? Not really, right? All right. So it defaults to graphing an x-min of negative 1 and x-max of positive 1, and then it just figures out the y-min and the y-max that it needs. But it may not look like the negative 4 slope, right? Shouldn't that be really steep? Okay, so I can fix that. I could say, okay, right before you close the parentheses, you go comma, aspect ratio with an underscore in between equals 1, then run it again. Well, this is really slow, but there you go. That's a negative 4 slope, right? Okay. Now I want to graph that line and see where they intersect. Who's stuck? Anyone stuck at this point?
Yeah.
Did you get a grab?
Oh, no, I didn't.
Okay, it's just slow, that's all, yeah.
Okay.
You're okay? And it's, yeah, there it is, there it is. Okay, how you doing? Make sure no space. Most of the network is fine. We have a little green line there, it's thinking, so okay, it's doing something. I can't. It's low base here. But that's not too bad. All right, well, if you save it, Alright, what's gonna happen is you're gonna get the opening screen where you created the worksheet in a minute, I don't know how long. And it'll say your file names, you click on it, and then it should work. Okay, so just wait for a minute. And by the way, there's a lot of ways of running saves. You can run it this way over the internet. You can run it over with a CD. They have an ISO you can download and burn, and just reboot your computer with the CD. But that's a read-only file system, so it's going to be hard to save your work, unless you have like an FTP set or something to save it. You can also install it on your hard drive, but it's Linux-based, so you can't use Windows, you got to use Linux. I use Linux at school, I don't know, does anyone else use Linux? No? All right, well, let's see what's next. Well, let's put up the other line. Now, when you want to plot more than one thing, you got to put it in parentheses, make a list of the functions, and separate it by commas, like that. Now you should see both. And I apologize for this, the speed of this network. I've given this talk elsewhere without such problems, but okay. Come on. Wow. This is way slow. This should be like this, you know? You still waiting too?
Yeah.
Well, there should be a little green line next to evaluate. It means it's like actually doing something. So hang out. It's usually doesn't mean hang out forever, but good. Come on. Mine is stuck too. What the heck is this? Did yours come back?
Yeah, now I'm waiting again.
Yeah, no, you click the evaluate again?
Yep.
Well, we're not going to get very far today if it's going to be this slow for every single little thing I want to do.
Just remind me, I'm not trying to be like that. Why would we be using this? I
Well, because, eventually I'm going to show you some stuff that you can't do in the file. And it's also a programming environment. It's a mathematical programming environment based on Python. There's a lot of stuff you can do if you know a little programming too, which I was going to show you. But of course you can program on the TI calculator too. It's got TI basic. But Python is much more used much more in the math and sciences nowadays. And wow. I wonder if there's some way around this. All right, you guys wait for a second. Let me see if I can find a server that's faster. Hang on. Let's see. Yeah, this network is very slow in the school apparently. Because I use this one a lot in my school, no problems, every day, all day. So what the heck? that's not possible.
Do you use this with students that have taken computer programming already?
No, actually. Well, yes and no, both. I have a class called Computer Math, which is like the year before they take AP Computer Science. So this is like their first introduction to programming, but it's really, we have a textbook that uses Python, but it's really about discrete mathematics. So they're learning how to program, and they're learning the system, but they're also learning discrete math. That's our Computer Math class. But we also have a calculus research lab for the calculus kids. That's not required, because they're so overbooked, these kids, it's really hard to schedule. But some kids who might have time to do it, I have them every other day in a lab setting, in a computer lab setting, sort of like a science class has a lab every other day. And we do this, we do calculus on here.
Yeah.
You know, so. Yeah, we used to have do Visual Basic. Now we're doing the Python stuff. So
Same idea, I guess.
it's similar. It has the same learning curve. It's much more powerful, but it's easier to learn, I think. All right, now what the heck happened here?
All right, play Brian. I don't know.
Why am I not connecting to anything? Nothing is connecting. It's a networking issue. Well, that's the thing. It's all the whole rest of the talk is about Sage. The whole rest of this talk is about how to do all this crazy stuff in Sage, and how easy it is to scale to any level. You can do arithmetic, you can do algebra, you can do geometry, you can do calculus, you can do statistics, you can do matrices, you can do all kinds of stuff. You can do programming, you can do computer algebra stuff. In other words, it'll give you algebraic results at the TI-89, the TI-200, those calculators. Come on, baby. Oh, well, mine graphed. Did yours graph?
Yeah, I finally got a graph.
Oh, finally we got a graph. Okay. All right, now, what's different here is on the TI, you then trace or super trace, and you get the intersection point right there. Not in this environment. What you do is you use the solve command, okay? So let's try that. All right, so just click on an open cell, or click on a bar if you don't have an open cell to get one. And I would say solve, open parentheses, f of x equal g of x. Equal is a Boolean operator. It's either true or false, okay? What the solve command does is it finds an x value that makes it true. So there's two kinds of equals in here. There's equals, and there's single equals. Single equals is an assignment statement. It changes the value of the left-hand side. That's not what I want. So if you say solve for, I don't know, solve for x, you can find x, hopefully. And we know x. Do you remember when we did it on the calculator? We got, what, negative 0.5, I think it was? And there it is. And it's giving it in pretty print and so forth. You could probably get a numerical version of that if you want. I think if you just say n of that, it gives you the numerical version if you want it. Come on. Come on, you can do it. Did you get it?
No.
Wow. Oh, wow. Okay. It's giving me a lot of errors because it's losing connection with the server, and so it doesn't know what the heck's going on. So let's not worry about that. Okay. Let's see. Now, of course, we got negative 1/2 for x, but how are you going to get y? Well, you could just say, well, what's f of negative 1/2, right? And that should be the same as g of negative 0.5. Right? In fact, f of negative 0.5 is equal to g of negative 0.5, isn't it? Damn you. Oh, I put in, oh, I hit the wrong key, or I didn't hit the space, whatever. And that's not doing it. That should say me, it's acting strange because it's losing connection. It should have said true. It should actually evaluate the word true, but all right, whatever. Now, at this point, before we go any further, I really have to get you to understand the underpinnings of the Python. The glue of the system is Python. It puts everything together. So I'm going to talk a little bit about arithmetic, a little bit about algebra, and then we can continue with the packet and do the matrix stuff. Because remember, the original question was, can you solve this with a matrix? Okay? So, first thing I got to tell you is that there are 7 operators, no more, no less, 7 operators in Python. What do you think they are? Give me one.
I'm just gonna let them know, maybe they can send me IT.
Okay, well, it seems to be okay right now.
Yeah?
Yeah. And then it's the wireless thing, slow. Well, you guys aren't wireless now.
Yeah, but they're not.
Yeah, you're not wireless.
Let me just let him know.
Okay.
Let him,
So, what do you think is an operator in Python? Just like in your graphing calculator, what operators are there? Adding, arithmetic, subtracting, multiplying, dividing, right? Okay. So you could say, I don't know, 2 plus 7. And just in case you didn't know, it's 9, okay? All right. 2 minus 7. I don't know why I like 2 and 7 today, but there you go. 2 minus 7. All righty. 2 times 7, shift 8. The minus is the dash. 2 divided by 7. Well, yeah, thanks a lot. What if I wanted the decimal version? And I hinted at this a minute ago. There's a way to convert it. Yeah, there's the n function for numerical, right? So, you know what? If I twist this a little bit, it might be easier. What if I do the numerical version, or I could do it right here. Let's see, let's do it right here. Put n, open parentheses in front, and close the parentheses, and you get the numerical version. Okay, now I think we got a better connection. Is everyone going quick? No? Well, you can just watch if you want. Okay, what if you don't like that? What if you want more decimals? This is calculating this on the fly, on a supercomputer. Okay? It doesn't have this answer stored anywhere. But I could tell it to find, I don't know, 100 digits of that
It
answer.
does have to do with the college and
Yeah.
not much of
Yeah, that's what I figured. All right. You know what? I'm going to take pretty print off so that it doesn't go off the screen. The long decimals go off the screen in pretty print for some reason. So it's just so you can see what the answer is in one screen. There you go. All right. I can make that maybe a little bigger so you can see it better. Is that okay? Maybe a little less. Okay. All right. How about, hey, that's not enough. How about 1,000 digits? Okay. How about 10,000 digits? This is calculating on the fly in the supercomputer. Now you can start talking with the kids. This is an arithmetic, a class that's doing arithmetic, right? And talk about, wait, what's special about this number? It's repeating. Oh, look, what's repeating? 285714, 285714. 2 sevens is a repeating decimal. What do you call that? That's called rational number and stuff like that, right? Okay.
Do you get more digits on the TI?
No, the TI can't go this far.
I don't think you have a relationship with
Nope. The TI-83, if you're dealing with like exact integers, let's say powers of 2, not even decimal, the largest you can get is around the Google before it crashes. I think like 69, is it 69 factorial?
So my question is, for instance, like if you're teaching them to go 2 divided by 7, you can't be sure.
Right, there's only so many significant digits the calculator can handle. The TI-83 it's less than 100 digits, whether it's a decimal or not.
It only shows.
Yeah, on the TI-92, it's more. It's maybe 400 digits. But this, we're already up to 10,000 digits. All right. Well, but wait. I thought I said there were... all right, I'm going to make this small so it doesn't take up the whole screen. How about that? I thought that I said there were 7 operators. That's only 4. What else do you think there might be? I'm doing arithmetic. This is an arithmetic class. Powers, okay. But yes, that's a 5th one. But what if I told you there's 3 flavors of dividing? There's 3 kinds of dividing. There's this kind of dividing, the normal kind that you would expect, right? There's also this kind of dividing. And there's also this kind of dividing. What the heck is that? I'll give you a hint. Maybe this might be easier to figure out. Any idea what I'm doing?
Yeah, like some remainder of-
The quotient, the integer quotient and the integer remainder, right? Okay, we call that div and mod. We have divide and we have div and we have mod. Okay, the slash slash is div. How many times does 3 go into 16 at most? 5 times. And then mod. 16 mod 3, what's the remainder? 1. So if you need to do remainders and stuff like that. Then, as you said, there's powers, right? How about 2 to the 7th? I don't know why I'm hooked on 2 and 7 today. That's not 2 to the 7, sorry. I take that back. It's 2 times symbols. Okay? Now, this was recently added. How do you do exponents on the TI-83 calculator, 84 calculator? The caret, right? Yeah, that was recently added. That's not part of Python, but they added it to Sage because people like the caret thing, so I could use caret too, but I don't feel like it. Well, okay, look, here's a caret just for fun. Okay, so it works, okay? But this is how it's usually done. Well, how about if I do to the 77th? How about if I do to the 777th? How about to, I don't know, 700,777th? Now look, Sage got a little lazy. Look what Sage did. He says, output truncated. This answer was so large. This is one number. This answer is one number, right? 2 to that power is one answer. It's so large, it gave you 100 lines full of digits. Gave up and gave you the last 100 lines of the answer. Because that's just wasting way too much space. But the whole answer is here in a file that you can download, print, whatever the heck you want to do. If you open it up, there it is. And you can, format it in Word or something if you really need to print this out for some reason. It's all there. How many digits is that? Do you have any idea how big that number is? 2 to the power of 2, that's 770,777 in the exponent. Yeah, let's count it. Exactly. Okay, so let's do that. In fact, I'm going to do that. I'm going to now switch from arithmetic to string operators. If I convert this thing to a string, in other words, pretend that it's just a bunch of characters, a word, a big long word, I can convert it to a string. And what's nice about strings is I can count how many letters there are in it using a string function called length, L-E-N. Okay, guess. What do you think it's going to be? How big do you think it's going to be? How many digits did it just show? 2,000? 234,135 digits. Sorry, we're a little off. Yeah. All right, so that's arithmetic. All right.
Can I ask you a question?
Yeah.
Have you ever used this for like a Regents level class?
Yeah.
Yeah?
Mm-hmm.
And like regular Regents level, not honors?
Oh, yeah. Yes, sure.
I feel like chaos will erupt if I ever tried to do
Well,
anything
yeah,
like this.
it can be confusing. It depends. Are you interested in teaching them how to use a TI calculator? Or are you interested in teaching them the math? If you don't really care about the calculator that much, you use this instead. You can't do both. That's
Right, that's
confusion.
the thing.
That's mess.
So
Yeah,
is
I
it-
tried that.
Right.
Don't do that. If the kids need to know how to use the graphing calculator for like the next year's course or something,
That's the thing.
you're really going to have to just focus on that and forget this.
And then I feel like this is something that should be used all throughout high school because it would
Exactly.
take me 4 years to live through this.
Well, it does take a little while to get used to it, but once you get used to it, it is intuitive. I mean, think before you ever touch a TI graphing calculator.
Yeah.
At first, you didn't know what the hell to do with it, and then eventually it became intuitive, and you got used to it. And it's the same thing. There's a learning curve. It's not that bad. But what I'm thinking is that there's so much more power behind this, using it on the PC rather than a handheld graphing calculator. These handheld graphing calculators are going to reach a limit whereby they can't compete with this.
Every kid has a computer for them when they're doing it.
Well, yeah, my classroom has always had a computer for every kid. Yeah. Yeah, I have a setup where I took 2 rooms, I blew out the middle wall, and I really have a double wide room. And so the kids always joke that each one of them has a computer desktop and a wooden desktop. So if they're taking a test or something, like, the first thing they want to do is they want to take the keyboard and move it on top of the monitor to do their test, right? And it's like, first thing I do when I give a test, I say, don't move the hardware, move your chair. And they just slide over, and they got a traditional wooden desktop. Imagine that. So everyone's got two desktops, and electronic and wood. So, I mean, that's how you have to design your room, I guess. That's up to your school and what you want to do with your kids. And this is something I've been developing in my room since, 1985 at Baldwin. Okay. What else? Okay. All right. How about, let's do a little more arithmetic. Just let's keep it simple, because you're like getting freaked out with high school students can't handle this already, right? Okay. Have you ever heard of Mersenne primes? What's a Mersenne prime? What's a prime? Prime number. A number that has exactly two distinct factors, one in itself, no more, no less. So I go through this with my kids. Is the number 1 prime? No. Is the number 2 prime? Yeah. Is the number 3 prime? Yeah. Is the number 4 prime? No, and so forth. The only prime number that's even is, right, all prime numbers are odd, right? You do this whole thing with the kids, right? Okay. Well, Mersenne had a lot of time on his hands, I guess, and he wanted to figure out large prime numbers. In his day, I think in the 1700s, they only knew as a few prime numbers, maybe up to maybe 3 or 4 digits. And he's like, how can I figure out really large prime numbers really, really fast? And, no graphing calculator, no supercomputer, no nothing. I think he was a monk or something, okay? So what he did was he said, well, look, powers of 2 are always going to be even, right? Any power of 2 is even. Okay, what if you subtract, well, let me start with this one. What if you subtract 1 from it? Well, now it's going to be odd. But wait, it's also prime. All right, then he said, well, look, powers of 2 get really big really fast. And if all I have to do is take that even number, subtract 1 from it, make it odd, and in fact, prime, I got big prime numbers really fast, right? So he says, okay, is 2 to the 2 minus 1 prime? Yeah. Is 2 to the 3 minus 1 prime? Yeah. Is 2 to the 4 minus 1 prime? Ah, dang it. I screwed up. This is Mersenne talking. All right, then he modified his theorem. He said, oh, wait. Numbers 2 to the n minus 1, they're odd, but they're not all prime. How about 2 to the prime minus 1? How about we put in known primes? We got a bunch of little known primes. If we make them the exponent of the power of 2, then it's going to get really big really fast. But I think if I put a prime number in, I'm going to end up with a prime number out. All right, let's see. So I put in 2, I put in 3, I put in 4. That's not prime. Don't do that. Put in 5. And that's prime, isn't it? It is, right? And put in, well, what's the next number I should put in after 5? 7. Okay, not 6, right? And then now the numbers are going to start getting sort of big and hard to check. So I'm going to write a program. I'm going to use Python to do that for me, automate it. It's going to plug in 2, it's going to plug in 3, it's going to plug in 4, it's going to plug in 5, but it's only going to print out the numbers that work out to be prime. Okay? So this is called a looping structure. Every programming language has one. How about a for loop? This is how it's done in Python land. Are you ready? Here we go. Try this. For some dummy variable, I, in range, let's say 2 to 10. Let's start there. Colon. Now colon is part of the syntax because when you hit enter, it'll indent for you. I don't know if you've had any experience programming with what? In Fortran? Yeah, okay. But in Fortran, don't they have like braces in the body of the loop? A lot of programming languages like C, C++, Java need braces, right? Here we don't do braces. We do the colon, which tells it to indent. Then everything indented, this is part of the syntax, everything indented is controlled by the loop. You don't need braces. All right, so what am I going to do? I'm going to, let's see, I'm going to print 2 to the I minus 1. Okay? Oops, I meant I. What happened there? Right. So what does range 2 to 10 do? It counts from 2 to 10 as integers. I don't think it actually does 10, it does one less. So it's going to plug in I is 2, 3, 4, 5, 6, 7, 8, 9. So there should be 9 outputs, right? And so if you just do Shift Enter, there you go. Now that's not checking if the answers are prime or not. Didn't we get 3, 7, 15? Oh, bad. 31. We didn't do 63. We skipped that, right? 2 to the 6 minus 1. 127, 255. That's not prime. What? Okay. I got to fix that. How about if I say, instead, let's say m equals that, and then I do a question. I'm going to question this. I'm going to say if m dot is prime, colon, enter, then print it. So I'm using a variable m to keep track of the number, so I can test it before I print it. And now let's see if the output's different. The output right now has 2, 3, 4, 5, 6, 7, 8, 9, right? So 1, 2, 3, 4, 5, 6, 7, 8 outputs, right? So now it only has 4. And those 4 are in fact prime, aren't they? Okay. So, what if we up the ante? Plug it up to 99. It'll count from 2 to 99.
What would the student ask you if the computer can figure out it's prime or not? Why should you say print prime?
Well, because I'm investigating Racine pattern of primes, not just any old prime. Yeah. Okay. So now we're starting to get some really big numbers really fast. Let's see. So Racine was right. This is a good algorithm to find big prime numbers really fast. But now look how big this is. If I'm plugging in I is values from 2 to 999, almost 1,000 inputs. I'm not getting 1,000 outputs, am I? There are very few of those numbers that are in fact prime. I only got out of those almost 1,000 inputs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is one big long output because look, see this thing that says it continues to the next line. So 6, 7, 8 prime numbers that are Racine, up to 2 to the 1,000 minus 1. All right, so that's just like really quick, powerful, computational, number crunching stuff. All right, so that's arithmetic. Okay, how about some algebra? This thing can factor, it can FOIL, it can differentiate, it can do all kinds of stuff. Are you ready? All right, let's try it. Anyone stuck up to here? Are you guys just like following along? Is that it? Yeah? Okay. If you're trying to keep up with me, let me know if you're stuck, on your computer. All right, how about this? What is x plus 1 to the 0 going to be? 1. Yes, come on today. Come on, we know the answer. We don't need you for this. Okay. Then x plus 1 to the 1 would be, x plus 1. Okay, today. Okay. And x plus 1 to the 2, and so forth. What am I whoops. I have to, Sage, you're lazy. I'm going to say expand. It doesn't want to expand it unless I say so. So it's foiling it out, and boom. And what am I generating, really? Does this look familiar at all? Look at the coefficients. 1, 1, 1, 1, 2, 1. Pascal's triangle. In fact, it's a binomial expansion theorem using Pascal's triangle. Could we automate this? Let's let it put in all the powers. I don't have to type this 500 times. Okay, here we go. For I in range of, 0 to 9, because we started with 0, right? So start with 0. Whoops. Is that it? Whoops. Comma. Colon. Let's see. I'm going to print, expand, quantity, x. Well, I could have just copy and pasted that. X plus 1 to the I. And let's see. I've got to close my print statement. I messed up what I do. Open. I have 3 opens. So open, close, open, close. Whoops. I forgot to close. There you go. And that's a binomial expansion theorem for powers from 0 to 9 so far. And I could go further, but it's going to start wrapping around and be a big mess. I don't want to get into that right now. But there's a lot of algebra you could do here. You can factor stuff. What if I said, let's see, how about this? Factor, damn it. I can't type standing up. Okay, factor, something like this. 6x squared, no, 6x squared, like that, plus 11x, explicit multiplying, plus 3. Now, can you do that one in your head? I think it's factorable without, quadratic formula or anything. You guys do tricky try? Is that what you guys call it? Every school calls it different. Master product factor? Yeah. So you're looking for two numbers that multiply out to 18 and add up to 11, and is there such a thing? 2 and 9, right? Is that right? Let's see. Again, I don't know what chalk is. So. Let's see. 6x squared plus 11x plus 3. You do, some people call this the eyeglass theorem.
Yeah.
Right, so the master product is 6 times 3 is 18, but the sum, just like any other quadratic, is the middle. Can you think of two nice easy integers that multiply out to positive 18 and add up to positive 11? 9 and 2. So what I do with my kids is I do this. If you're solving for zeros or something, that's how you solve it. Do you set it up that way? Everyone does this different.
Divide it, yeah.
Well, yeah, because, right, but if you're not solving, if you're just factoring, you're not going to get complete factors, right? But the thing is, if you did it right, this goes away. Is there a greatest common factor here? What's the greatest common factor here? 2. What's the greatest common factor here? 3. 2 times 3 cancels the 6, so take out the 2 and take out the 3. And that should be the answer, right? Did you evaluate that yet? That's what Sage should give you. Okay, let's see. Shift enter. There it is. Well, not in the same order, but multiplication is commutative. Big deal. 2x was 3. Yep. 3x was 1. Yep. Okay. So you can get into factoring quadratics, anything to do with the greatest common factor, or difference of two squares, or quadratics, or master product algorithms, stuff like that. I recently just did in my pre-calc class the sum and difference of two cubes, and they weren't getting it, so I just wrote up a whole ton of them on stage on the board, and they got the pattern. This is nice for pattern recognition, just like what-if analysis, like practice, explore, right? What if I said factor the sum of two cubes, x cubed plus 1. All right, factor, I don't know, let's see, 8 times x to the third minus 27. That's the difference of two cubes, isn't it? I messed up. What did I do? All right, why did my x key got stuck? Wait, hang on. I typed it twice for some reason. All right, and then so I pull it out of them. I do like a whole ton of these, and not just 2 of them, right? I do a whole ton of these, and I pull it out of them. I said, what's being cubed here? X. What's being cubed here? 1. What's this thing squared? X squared. What's this thing squared? 1. What's 1 times x? X. What about the signs? If that's positive, that's positive. If that's positive, that's negative. Do it again. What's being cubed here? 2x. What's being cubed here? 3. What's 2x times 2x? 4x squared. What's 3 times 3? 9. What's 3 times 2x? 6x. If this is negative, this is negative, this is negative, this is positive. We do this like 50 times, and then they finally got it. So then they can solve equations that involve difference in sum of two cubes and all that fun stuff, right? All right, how about this one? What if I said factor x squared plus 2 times x plus 2, and Sage comes back with, well, screw you, I can't do it. Well, why not? Well, look at the discriminant. It's not going to factor unless it's not going to show you a factor that's not integer-wise factorable like we do in our heads, right? The problem is that the roots, if you set this equal to 0, the roots are complex. Oh, okay. So then I get into discriminants, and we write programs about quadratic formulas and all kinds of fun stuff. But then we said, okay, what if we solve that thing? you get your complex roots. Okay. Then I perturb it a little bit. I said, okay, take the same thing, copy it, change it a little bit, and make it plus 1. Make it plus 0. Make it minus 1. And what happened? You have all 4 cases of the discriminant. Okay? Complex conjugate roots, real, rational, equal, real, rational, unequal, real, irrational, unequal. And then I go, well, why is that? Why are we getting roots like this? Then we go, okay, well, let's plot it. Plot. This guy. No, not the whole thing. I'm just copying and pasting with the mouse, right? And let's see what that plot looks like. Maybe that's not a good window. If you want more than -1 to 1, you just list it. Negative, I don't know, 5 to 5. So why are the roots complex? This is what I do with the kids, right? Why are the roots complex? Well, guess what? It doesn't hit the x-axis. Look at it. All right. And then you go, all right. Well, then compare that. All right, let's make a list. Comma. Then you do the plus 1, 1. And so why did this one have real, rational, equal roots? Well, look at it. What happened? It just taps the x-axis. There's only one root. Okay, fine. And then we do the other one graphically, which was plus 0, technically, for C. And then there's 2 roots, and they look pretty nice. It looks like you can eyeball it, 0 and -2, although I wouldn't take that as an exact answer on the test. I would do the solve key, blah, 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 which we did already. And then what about the irrational case? What did that look like? That was, whoops, that was -1, right? Okay, and if you don't like that graph, you can play with the x min, x max. How about from -3 to 0 or something? Right, that might make it more obvious what's happening. No roots, repeated roots, 2 rational roots, 2 irrational roots. If you don't like what that looks like, you can play with the aspect ratio. Maybe that might make it more readable. Oh, come on, don't fail me now. You're just starting to speed up. Everything's just going good.
Do you let them use the start test?
If it's a class where they've been using this, yeah. If it's a class where they're primarily using graphing calculators, no. We'll use the graphing calculators. So there you go. There's a nice graph. If you don't like the y min and the y max that it selects for you, then you can change it. Whoops, did I put a comma there? No. Let's say y min of, I don't know, -3 and a y max of +3. Okay, where am I? There I am. Oh, there's a lot of stuff you can do here. Come on. Nope, didn't do it. Something got screwed up here. Somehow this got... Oh, I did it. Okay, there I did it. Okay. You can change the color of each graph. You can do all kinds of crazy stuff. All right, now how are we doing on time? Okay. We got, well, this was optionally a 90-minute presentation. We're almost up to the 75-minute mark. So it's up to you. I can stay till 3. Or we're almost done. What do you want to do? You want to keep on going till 3? You want to stop at 2:45? It's up to you because it didn't say in the you're done? All right.
Yeah, it's 2:45 to 3.
Yeah, it could say up to 3, but if you had enough, you had enough.
Yeah, right.
Okay, all right, so. Okay, so like I said, if you want to play around with this, it's free online, www.sagemb.org to make a worksheet, www.sagemath.org to get documentation how to do stuff. I just scratched the surface arithmetically, numerically. I didn't even get back to doing that with the matrices, but I was going to do vectors and matrices in 3 space, but that's fun. but not today. Okay, so thanks for coming. And don't forget to return your evaluation forms at the registration desk.
Okay, I need the evaluation.
Oh, you're taking it? Okay. I guess you can.
Okay.
Bridget, I already dropped right off at the.
Oh, you did?
Yeah.
Oh, okay. Good. You just love math and it comes right through.
Well, we try. Been at it for a while. Well, we're trying to find different ways of getting the kids engaged and understanding things better, and the technology is always changing. It's a good way to go, I think. Yeah. So. Yeah, we were supposed to have 7 people. One person didn't show.
Yeah, I don't know.
And those
You
2
had
ladies
less.
said that they were elementary.
They were, yeah.
So they got a little bit,
I just want
overwhelmed, I
to find
guess.
out their name, or
I don't know
But
who they
if-
were.
Once I know theirs, then I'll know who left. When you need?
Oh, that's, and more.
Jessica and
Jessica
Dawn.
and Dawn? Okay. Okay. All right, so they said,
Yeah, they said they were elementary. There was one girl there that stayed. So, not that we're taking it.
no, well, just to get an idea.
Okay.
Thank you.
You're welcome. I hope
Oh,
that
thank
helped.
you.
Yeah, you can move forward anyway.
Okay.
My kid was using my laptop last night to Skype her great uncle,
Yeah.
and she must have lost or misplaced the power cord of my smart tab, because I wasn't going to do that.
Yeah.
I was going to do my smart tab.
Yeah.
But whatever. I literally haven't touched a short.
Maybe it'll turn up. Oh, and this was,
Oh.
yeah. That's all right. It's not a thing. So.
Okay.
All right.
All righty.
Good evening. Thank you.
Thank you.
Bye-bye.
All right. Well, I guess if this is going on YouTube, we'll have to say goodbye to YouTube. Let's see. Let's get rid of this. Let's get rid of that. Get rid of this. Let's see. Get rid of this. Alrighty. Get rid of this. Get rid of that. And let's stop the recording.